So if the two pieces of tape are just sitting on the table, they're just neutral because nothing's been done to them. So it's not until you pull off the top piece of tape that there is a transfer of electrons. And we kind of went into that with investigation 17 because we're talking about there was work being done. So that work being done ended up in a transfer of electrons from the bottom piece of tape to the top piece of tape. Oh, I'm sorry, I just said it wrong, didn't I? Sorry, electrons being transferred from the top piece of tape to the bottom piece of tape. So we already have this answer, right? What is therefore the charge? So we're looking at the two pieces of tape. The top one is positive, it has lost electrons, and the bottom piece is negative, it has gained electrons. And why is this? Can someone remind me? Just pretty much restate what I just said. Sophie.
Because the interaction between the two different materials, even though the bottom one is not actually doing, it's not sticky, it's getting the electrons transferred to it because of the way the sticky and smooth interaction.
Okay, that's good. So this is just a close-up view of what we're seeing here. So that bottom line is the bottom piece of tape, and the top rectangle is the top piece of tape. Those two arrows are there because the red one doesn't show up in the other room. So I had to redraw it. So now you're seeing two arrows. Anyway, all the arrows are showing is that the electron, which we're showing by the circle, is moving to the bottom piece of tape. So there is a transfer of electrons that results in the two pieces of tape having different charges. Which brings us to our question, why does a fun fly stick make a butterfly mylar ring fly? In this picture you see an open view of the fun fly stick. In there you have this Teflon pulley and a rubber belt. If you think of the way this rubber belt is going over the Teflon pulley, it's like rubbing a balloon on a shirt a lot of times. Many, 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 many times. Therefore, just like the balloon is left with an excess negative charge on it, with the shirt being left with an excess positive charge, in that same way, the fun fly stick is left with an excess positive charge. So when we look at the mylar butterfly and its interaction with the fun fly stick, what we're seeing here is this close-up of the butterfly wing again. It is neutral and polarized. It is neutral because there is a separation of charge. It is polarized, other way around. It's neutral because it has not lost any electrons at this moment. It is, so for the electron hasn't lost any electrons. They haven't left the system. They have not transferred out of the system. And it's polarized though because these charges are separated. The electrons have sort of moved or migrated closer to the fun fly stick. The fun fly stick has a positive charge on it, so therefore the electrons from the butterfly wing will be attracted to the fun fly stick. But of course, as a consequence of this, what you see though are those electrons in the fun fly stick moving away. So now the butterfly, because they're attracted to each other, the butterfly mylar ring sticks to the fun fly stick. And what do you see happening in the picture on the right?
The electrons move over.
The electrons move over from where?
The mylar butterfly to the fun fly stick.
Yep. And why do they transfer over?
Because it's touching a positively charged object.
Okay, perfect. So it's touching I can't even say it now. Touching a positively charged object. Perfect. So what happens next? The mylar butterfly, or actually it's no longer a butterfly, the mylar ring now repels because like charges repel. So as you can see, there are still positive charges on this Mylar ring. They're still there. I'm sorry, there's still negative ones, but there are less, so you have more protons or more positive charges than negative charges. So something I want you to take away here is being able to distinguish between polarization, something that's polarized, and something that's charged. So charge, we're talking about electrons being transferred. Polarized, we're just talking about things being separated, but charges not leaving a closed system or entering the closed system. We have electrons being shown by circles in that model, that circle dot model. And a way to show that electrons are being transferred is in this diagram here. Consequently, what would be the charge on this dot here? What would be the charge of that?
Positive.
That would be positive. In this here? This piece? That would be negative. Okay.